Okay, so now I'm going to be covering transformations of absolute value functions. So as you can see here, y equals the absolute value of x. This is, again, my parent function. We call this the parent function. And it's the simplest form of absolute value functions. This graph, y equals the absolute value of x, it has no vertical shift, it has also no horizontal shift, and it also has no stretch, and it also has no compression. So this graph will pretty much look like this: a slope of 1 this way, and a slope of 1 also this way. One more up. So this is pretty much y equals the absolute value of x. Now the rest of my graphs that I'm going to be drawing originate using this graph. So I'm pretty much looking at this graph, and whatever I change to this, it's going to represent also a change on my graph. So I'm going to start with what I think it's like the simplest thing to look at, and that will be k. When changing k, notice k is outside of the absolute value. K, it's like you have the absolute value, you have your a, which is being multiplied to the absolute value, but k, it's just a number right there, just being added to everything. So I'm going to make an example where I have y equals my absolute value of x. Right now, they are the same thing. If I add, let's say, plus 2, that's a vertical shift upwards. Upwards because the number is positive. If it was negative, then it would be downwards 2 units. So it's a shift upwards by a factor of 2. So I would have to take this graph pretty much, the same graph, and just shift it over up 2 units. So it'll be up here now, and it'll go, sorry for this whole terrible thing. Well, it keeps going straight that way. And then over here, it does the same thing. It keeps going straight that way. So again, this is going to be a V-looking graph like this one, which also keeps going everywhere. Again, these are now the same graphs. It's just that this one, it's shifted 2 units up. Now let's say that instead of shifting it 2 units up, let me now shift it 2 units down. So I would have y equals the absolute value of x minus 2. So again, I would take the same graph, and I would take it 2 units down, and from here it'll go that way, and it'll go all the way that way. Of course, this side here, of course, keeps going so that way as well. Yeah, look, it's pretty much the same graph, just shifted 2 units down. And that's k. This value represents k, this value represents k. It's a vertical shift. Now the second one that I look at, it's my h. Notice that h is being added to x inside the absolute value. So for me to be able to identify k, I would have y equals the absolute value of x. If I add something or subtract something, that is going to be my h value, because it's going to be inside of the absolute value signs. So let me add 2. There you go. This is my h. And this is a tricky one, because the positive doesn't go to the positive side. It actually goes to the negative side. So here, the absolute value of x plus 2, it'll be a horizontal shift. 2 units to the left. So again, I'll have my same graph, but it shifted only 2 units to the left. Same graph, but it just shifted 2 units to the left. So nothing happened to my graph. Look, notice that all my graphs are the same. They are the same wide. They have the same width, but they are just being shifted. This was just a horizontal shift 2 units to the left. That's pretty much H. If it had been, let's say, y equals the absolute value of x minus 2, then my graph will go to my left, to my right. So I'll pretty much have my graph originally here, and it shifted 2 units to the right. So 1, 2 units. So my graph would now be here. And it goes over that way. And it goes over that way. And it's the same graph, but now just shifted 2 units to the right. Now I have my last variable, which is A. And again, A represents horizontal stretch or horizontal compression. So let me notice that A is pretty much the number that is going to be multiplied to the absolute value. So down here, I'm going to have y equals, let's see, 3 absolute value of x. So notice that this is A. The 3 is not being added over here. It's not being added anywhere. So this is not K. It's also not being added inside of the absolute value symbols. 3 is being multiplied to the absolute value x. So here, my graph, it's gonna have pretty much a slope of 3 over 1. So pretty much my graph, again, starting there, it doesn't have any vertical shift. It also doesn't have any horizontal shift. So we start at the center. And this is going to be, it has a slope of 3 over 1. So it goes up 3 and over 1. It'll go actually, it also goes the same side, the same way on the other side. So my graph looks like this, and it keeps going. My graph keeps going this way, upwards. Now, as you can see, this is a horizontal compression. So this is a compression by a factor of 3, horizontal compression by a factor of 3. Now, this is when this value it's greater than 1. If this value is greater than 1, we have a horizontal compression by whatever this factor is, if it is greater than 1. Now, let me do another example where A, instead of being greater than 1, is less than 1. So what about 1/3 the absolute value of x? Here we have the y equals 1/3 the absolute value of x, and we know that this is A because it is being multiplied to the absolute value. And this is going to be now a stretch because my A is less than 1. Let's see. I'll have my point here, and my slope will pretty much be 3 over and 1 up. Okay, 3 over and 1 up. Same on this side, 3 over and 1 up, and 3 over and 1 up. Now my graph looks sort of like this and like this. Now this is a horizontal stretch. And I got one more to go over. Let me draw another x and y axis. and that is if my a is negative. So let me have y equals the absolute value of negative x. If a is negative, which in this case is negative, also it doesn't have to be just the negative. We can have actually like, well, I'll actually show it right now. But just by x being by the absolute value being negative, this is a reflection, which will make my original graph, which looks like a V, regular V. It'll be the same V, but now upside down, like this. We get this upside down V by this being negative. Now, again, it doesn't have to be just a negative by itself. It can be a negative by itself as well. It can be a negative as well as a number like 1/3. Let's see what would happen if this number now became negative 1/3, the absolute value of x. Pretty much, I'll take this graph and flip it upside down. So my graph, it now looks like this. Now my graph was flipped. My graph was flipped and now it looks like an upside down V. But this is both a reflection as well as a stretch. Same thing happened with this. What if this, instead of being +3, it was -3, the absolute value of x? Same thing happens. It flips over. It'll flip over. Now this is, it's both a horizontal compression as well as a reflection. And this is pretty much it. Let me do one example where I have several of them combined. So let's see, y equals -1/3, the absolute value of x, -2, -3. Now this has several ones. So let me make a graph. I know it's gonna be something like this. All right, graph. Let me begin here at this point. So I get here, this represents of a vertical shift 3 units down. So let me take my point from the center and I'm going to go 3 units down. 1, 2, 3 units down. All right, 3 units down. It also say that this is a horizontal shift 2 units. Again, this is negative, so it'll go 2 units to the right. So I'm down here. Now I go 2 units to the right. Okay, so I cover the -3, I cover the -2. I still have to cover the -1/3. Well, the negative, it's going to make it flip. So I know it's going to be an upside down V. And my slope is 1 over, and I mean, it's 3 over and 1 up. So I know that's going to be 3 over. Again, it's upside down, so 1 down. 3 over and 1 down. Same from this side, it's 3 over and 1 down. And 3 over and 1 down. So my graph looks like this. This is my graph. Again, how did I get to this point? I know this is 3 units down. 3 units down. I know this is 2 units to the right. 2 units to the right. This is a slope of 1 over 3. So 3 over 1, 3 over 1, 3 over 1, 3 over 1. How did I know to count the 3 overs and 1 down? Because this was negative. I knew my graph had to be upside down. this is an upside down V-shaped graph. And this is the graph of this function. All right.